welcome to DIYguru. Previously, we have discussed about the batteries, right? We have discussed how you are going to judge the batteries, how you are going to select the batteries, on which parameters you need to select a battery, right? So, that is okay. Now, what about the types of batteries, right? So, there are different types of batteries we need to understand, so that in order to make a best electric vehicle. So, right now we are getting into the types of batteries of electric vehicles. Okay. So, there are different types of batteries in the market. The requirement serves the type of battery. New research is happening throughout the world every day to bring out the best technologies which helps EVs. Okay. So, the best known and mostly wide used batteries in electric vehicles was lead acid battery. It is actually it was used, but right now they are using much more upgrade versions. Okay. And lead acid batteries are widely also used in IC engines. We will be discussing about those batteries in further sections, but let me give you the brief history of the battery. Okay. And the first battery term was invented in 1748. Okay. And 1792, Volta remarked his work for chemical cell, electrochemical cell. Okay. In the same way, 1959, they got invented the lead acid rechargeable battery. In 1886, Carl invented the carbon dry cell. In 1899, Junger invented the nickel cadmium rechargeable batteries, and 1950 alkaline batteries, and 1985 AGM batteries were invented. Okay. So, this is a basic history of invention of batteries. Let us go for the types of batteries. The four basic types we need to understand before entering into the electric vehicle manufacturing. Okay. So, the first is lead acid, the second type is nickel cadmium, the third type is lithium batteries, the fourth type is nickel metal hydride. Okay. So, coming to the lead acid, there are basically three types of lead acid batteries. Okay. One is flooded cell, flooded lead acid, second is AGM, third is gel. Okay. Let me show you a small video how lead acid actually works. What is the chemistry behind the lead acid battery? Previously, I even explained you that in batteries there are two main components, electrolyte and electrodes, right. So, what is electrolyte? Electrolyte might be a liquid, might be a gel, or might be a solid, right. So, let me give an example, okay, how this battery work. Yes, you can see over here, when there is a flow of electrons, okay, when there is a load starting, there is a flow of electrons, and this Pb is getting out from this electrode and forming PbSO4, and after electrons come to second electrode PbO2. Okay. So, it forms H2O and PbSO4 again. So, when it is a recharge, when we are actually recharging, the same chemistry it is going to be reversed. Okay. So, when we talk about the types of lead acids has three types. Basically, I hope you have seen in inverters. Have you ever seen the inverters in your home? You would have seen the big lead acid battery where you need to fill a distilled water after some time for every 1 month or every 2 months generally. So, that kind of a battery we say it as a flooded lead acid batteries. Okay. And second thing is a tuber AGM sealed lead acid battery. Okay. And right now I am having a AGM sealed lead acid battery in order to show you. Yeah. You can see over here. Okay. This is a lead acid battery which is of 12 volts. You can see this 12 volts 7 ampere hour, right. Yeah, 12 volts 7 ampere hour. This is a battery where it is completely sealed. It is said to be a sealed battery. Okay, AGM sealed battery. And coming to the gel seal type, okay, it is having a gel kind of a thing as a electrolyte in those batteries, in those kind of a batteries. Okay. I will be showing the gel kind of a batteries in next sessions, but this is how AGM batteries look like. Okay. I hope you got it. Okay. Next. So, that lead acid battery chemistry, previously you have seen a video, right, cathode and anode. There are two electrodes, cathode and anode, that Pb lead acts as a cathode and PbO2 acts as a anode. Okay. So, in discharge the reaction will be reversed. Okay. Like in recharge the reaction will be reversed. Okay. So, when we talk about the what is the best battery? What is the best battery in these three batteries? Okay, flooded or AGM or sealed? Yeah, we can actually say what are the VRLA batteries and AGM batteries having a little advantages over the flooded cell batteries. Okay. Why? Because flooded cell batteries are useful only to a particular requirement like inverters and all, but when coming to the AGM and gel, it is having a cell property. As it is having a cell battery, it is quietly used in many other applications like bikes, vehicles, and many other applications. Okay. So, you can see the advantages over here: higher energy density, lower internal resistance, lower self discharge rate, more resistance to freezing, more tolerant to vibration, maintenance free. These are the advantages for using the VRLA or AGM instead of flooded, where flooded is having a there is a chances of leakages of acid when we use a flooded cell. Okay. So, when we talk about the difference between VRLA batteries and a flooded cell batteries, as I said you before, flooded cell batteries is that the electrolyte in the VRLA is immobilized, that can be this can be achieved by using absorbed glass mat separators or gelled electrolyte. Okay. So, that is how the flooded cell batteries, AGM cell batteries and gel batteries of lead acid works. Okay. Now, when we discuss about the nickel cadmium, okay, so it is we can actually say nickel cadmium is the next level of a lead acid battery. Okay. So, nickel cadmium battery was considered to be one of the main competitors to the lead acid battery. Yeah, true. And you can see the chemical reaction also over here, like Cd plus 2 NiO2 plus 2 H2O gives you CdOH2 and 2 NiOH2. Okay. Yeah. On the negative side, operating voltage of each cell is about 1.2 volts. So, 10 cells are needed to each in each normally 12 volts. Yeah. So, as I said you there must be electrolytes in the battery, right. So, in coming to the nickel cadmium, we need 10 cells in order to make a 12 volt battery. Okay. That is what 12 volts battery, that is it. So, next coming to another battery type, lithium ion. Okay. Next coming to another battery type, lithium ion. You can see the video over here, okay, a basic video over here. Yeah.
The lithium-ion battery is the power source for modern electric vehicles. These days, everyone's heard of lithium-ion batteries, but what makes them so special? First of all, each battery is made up of many smaller batteries called cells. Let's take a closer look at one to see how it works. The electrical current reaches the cells via conductive surfaces, in this case aluminum on one side and copper on the other. And just as in every other battery, there's a positive and negative electrode called the cathode and the anode. The cathode, or positive electrode, is made of a very pure lithium metal oxide. The more uniform its chemical composition, the better the performance and the longer the battery life is. As you'd expect, the anode, or negative electrode, is located on the other side. It's made of graphite, a form of carbon with a layered structure. The battery is filled with a transport medium, the electrolyte, so that the lithium ions carrying the battery's charge can flow freely. This electrolyte must be extremely pure and as free of water as possible in order to ensure efficient charging and discharging. To prevent a short circuit, there's a layer placed between the two electrodes, the separator. To the tiny lithium ions, the separator is actually permeable. The experts call this property microporosity. Let's take a look at what happens when a battery is charged. The positively charged lithium ions pass from the cathode through the separator into the layered graphite structure of the anode, where they're stored. Now the battery is charged. When the battery discharges, that is, when energy is removed from the cell, the lithium ions travel via the electrolyte from the anode through the separator back to the cathode. The motor converts the electrical energy into mechanical energy, making the car go. The amount of energy available and how long the batteries last is closely related to the quality of the materials used. To sum it all up, higher quality, pure materials along with customized formulations lead to longer battery life and better battery performance.
Chemical reaction over here is has a little error. Okay, you can see in comment section that what is a real chemical reaction, what's happening behind the lithium ion. And let me give you another example of lithium ion. Have you ever used the laptop batteries? Okay, if you ever use the laptop batteries, then the laptop batteries are the one which is having the lithium ion. Okay, you can see there is a small casing, there is a little small casing on upper side of this complete battery, right. So, let this small casing actually do the what we say battery management system. Okay. It is actually a battery management system which protects this complete battery. Okay. It is completely an electronic part. Okay. So, in generally we use the lithium ion batteries in electric cars and laptops and mobile phones. Yeah. So, yeah, that is about our lithium ion batteries. Okay. And moreover, Tesla is also using a lithium ion batteries for their cars. Okay. Next, coming to the lithium polymer battery. Okay. So, what is a lithium polymer battery actually? It is actually a lithium polymer battery uses lithium metal for the negative electrode and a transition metal intercalation oxide for the positive. Okay. So, there is only a small difference between the lithium ion and the lithium polymer. Okay. Lithium polymer is little more flexible. Okay. You can, it is much lightweight. Okay. It is having much lightweight. Let me show a little lithium ion, or sorry, let me show lithium polymer battery. Okay. And see, this is a drone, it is a drone. So, generally lithium polymer batteries are weightless, and as it is a weightless, they are going to use in a drones kind of a thing, or toys, in few toys. Okay. So, let me show you the battery of lithium. Yeah, you can, I can show you. Yeah, this one, it is a very weightless and a powerful, very reactive, okay, a lithium polymer battery. And generally, if you want to use a lithium polymer battery in electric vehicles, you know what, we need to have a lots of protection circuit. Okay. More the protection circuit, more the battery is going to be safe, more safer the battery is going to be. Okay. So, the major reason why people are not going for lithium polymer in electric vehicles is the protection. The first point is protection, and second is energy density. Okay. Lithium ion is having lots of energy density compared to the lithium polymer. So, that is the reason we are using a lithium ion in electric vehicles rather than lithium polymer. Okay. So, in generally these are going to be used in drones and all. Okay. You can also see the chemical reaction in the slide. Okay. The lithium is thus both a reactant and the mobile ion that moves through the electrolyte, the overall chemical reaction you can see over here. And next, going to the nickel metal hydride. Okay. So, nickel metal hydride, this is somewhat special. Most of the electric vehicle developers, in order to make a low cost electric vehicle, okay, they are actually looking for nickel metal hydride. Okay. Let me show you a nickel metal hydride battery. Yeah, this is a nickel metal hydride battery I am having. I just got it from my old lab. Yeah, you can see this, right, nickel. It is having a 1800 mAh and 7.2 volts, 7.2 volts. So, nickel metal hydride actually give a lots of competition to the lead acid, okay, and nickel cadmium also. But when coming to the lithium ion, okay, nickel metal hydride having a little less energy density and a specific energy. So, people generally prefer lithium ion if they weren't considered about the cost, and people generally prefer nickel metal hydride if they consider about the cost. Okay. And coming to the nickel cadmium, whatever mic I am using right now, it uses a nickel cadmium battery. Okay. Yeah, And coming to the lithium ion manganese oxide battery. Lithium ion manganese oxide battery are generally used for electric buses. Okay. Lithium ion manganese battery is having a very slight difference from lithium ion cell. Okay. Here, yeah, a lithium ion manganese oxide battery is a lithium ion cell that uses manganese oxide inside. Okay. That's the only difference. Yeah, that's about lithium ion battery, but many people actually ask me the only one question, what is the difference between lithium ion and polymer. Okay. And if you can see this slide, have you ever worked on foldable mobile phones? Okay. When you work on foldable mobile phones or a foldable electronic things, okay, generally you can see actually see this in slide. Okay, generally people ask me what is the difference between the lithium polymer and the lithium ion batteries. Okay, you can see this in slide, like you can see the picture in slide. Have you, if you ever worked on foldable mobile phones or the foldable electronics or what we say wearable electronics, okay, in all those kind of applications we need a lightweight, we need a foldable like conditions, right. So, we generally use lithium polymer in those conditions, and in all the static conditions, in order to have a very high energy density, we use lithium ion batteries, that is it. Okay. So, yeah, now it is very important to discuss something about the specifications and parameters of all these batteries. Okay. As I also said you before, I will be showing you the difference between all the parameters of all the different batteries. Okay. Now, it is in front of you. Okay. First, let me start with the lead acid battery. Okay. Yeah. See, as I said you yesterday, what is the specific energy? Specific energy is nothing but the watt-hour per kg. Watt-hour, what is a watt-hour? It is the energy required per unit time. Okay. So, when we talk about the lead acid batteries, okay, yeah, lead acid batteries, it is a watt 20 to 35 watt-hour per kg. Okay. When we talk about energy density, 54 to 95 watt-hour yeah, per length. And what is energy density? Actually means energy density is nothing but the energy per unit area. It is not actually we say area, and we can also say it as a area. Yeah. So, coming to the specific power, it is approximately 250 weight per kilogram. Okay, per kilogram. And coming to the nominal cell voltage, it is 2 volts, and ampere hour efficiency, it is approximately 80%. Internal resistance, yeah, this is something I need to say before I get into another details. Okay. So, let me discuss about the internal resistance before I go into the another parameters. Okay. So, yeah, always remember, okay, whenever battery is actually giving you 12 volts, okay, it is internally producing 12.05 volts. Okay. So, like the first question, where this 0.05 volts are going. Okay. It is actually the voltage drop due to the resistance, internal resistance. Okay. So, in order to judge a battery, we can actually say lesser the internal resistance, okay, more power the battery gives. Okay. So, if more the internal resistance, the less power the battery gives output. Okay. So, it is one of the parameters we actually need to consider when we talk about the resistance. Okay. Next, coming to the operating temperatures. Okay. In lead acid batteries, the operating temperatures are very poor when we talk about cold conditions. Okay. When we talk about 5 degrees or 10 degrees or 15 degrees, it is lead acid works very poorly. Okay. It actually works better, very perfectly at 27 degrees centigrade. Okay. And when we talk about the self discharge, yesterday also I discussed about the self discharge, right. What is actually self discharge? It is the ability of losing the power, losing the voltage of the battery, even though it is left unused. Okay. Even though you are not using it, the discharge continues because due to some environmental effects and internal chemical composition. Okay. So, you can see it is approximately 2% per day, approximately 2% of power will be discharged even though you are not using it. Okay, these are parameters of lead acid batteries. Now talk about number of cycles. As I said you before, okay, if you charge your phone battery 5 times a day, what happens? Okay, within 6 months the phone get dead. Okay, why? Because the life cycles get completed. Okay. So, you need to consider number of cycles also, it is up to 800 cycles, 80% capacity. And what is the recharge time? Recharge time is 8 hours. For lead acid batteries it is 8 hours. Okay. Now, consider nickel cadmium batteries. Okay. Nickel cadmium batteries, as I said you, it is having a little higher specific energy than the lead acid. Yes, it is having a 40 to 55 watt hour per kg. At the same time, energy density is 70 to 90 and specific power is 125 watt per kg, and nominal cell voltage is 1.2, ampere hour efficiency is good, internal resistance is 0.06, okay, which is slightly higher than the lead acid and commercially available. And self discharge, this is most important. Self discharge, it discharges 0.5% per day. Okay, 0.5% of its power will be discharged even though you are not going to use it. Okay, even though you are not using it. So, number of cycles, it is 1200, which is slightly higher than the lead acid, and recharge time is 1 hour, and rapid recharge you can make it 20 minutes. Okay. So, this about nickel cadmium. When I go for nickel metal hydride, okay, this much more higher and much more better than the nickel cadmium. You can see 65 watt hour per kg and 150 watt per volume, and specific power is 200 watt per kg. Nominal cell voltage is 1.2 and ampere hour efficiency is quite good, and 0.06 is the internal resistance. As you can see, the 1.2 volt it is generating due to the little higher resistance. Okay. Yeah, and and coming to the self discharge rate, you can see poor, it is 5% per day. Okay, 5% per day, which means somewhat higher than the nickel, somewhat higher than the lead acid batteries. It is discharging much higher than the lead acid batteries. Okay. So, that is the reason they actually do a secondary reason for selecting the nickel metal hydride, and number of life cycles is up to 1000, 80% discharge rate with a charge time of 1 hour and capacity of 20 minutes. Okay. You can make there are 2 types of chargings. Okay. Always remember, you can make a rapid charging, you can make a nominal charging. Okay. A nominal charging is like nominal charging is nothing but you will be providing the constant current, basic current in order to charge the batteries. But when you coming to the rapid charging or a fast charging system, you need to provide lots of high current and high voltages. So, if you keep up rapid charging, it is how much? It is at 20 minutes, that is it. So, when we actually talk about the lithium ion, yes, this is the much more important and much more we need to discuss about it. Okay. Just compare it, it is having 90 watt hour per kg, which means higher than this and higher than this and higher than this. Okay. So, you can just compare the energy densities, each and everything, 153 watt per volume, okay, and specific power 300 watt, and nominal cell voltage is 3.5 volts, and internal resistance is very low, and ampere hour efficiency is very good. The operating temperatures are ambient, you can use it from like 5 degrees to 50 degrees anywhere. Self discharge very low, it is 10% per month. 10% per month, which means 0.3% per day, 0.3% per day, we can say like that. So, it is very low. That is the reason people actually use lithium ion for lithium like vehicle manufacturing, electric vehicle manufacturing. Even Tesla uses the lithium ion batteries for its vehicle. Okay. So, number of life cycles, you can see this very higher than the 1000, okay, and recharge time also 2 hours. Okay. So, as I said you before, this is a basic comparison between the different batteries you need to understand. So, by after seeing this, okay, you must be able to judge which battery is better for the usage of electric vehicles, like according to your requirement. And I cannot say you must always go for lithium ion. Okay, sometimes cost also needs plays a crucial role, right. So, you need to understand, we are saying the lithium ion like batteries are having a very good specifications, at the same time lithium ion is very costly, okay, very costlier than this all this. Okay. So, that is the reason, okay, we need to consider very costlier. So, that is about the differentiating all the batteries with the parameters what we have learned yesterday. Okay. So, yeah, we now that is it, that is about the differentiation of the batteries. And if we talk differentiation of the batteries, yeah, and in next session we are going to see about the charging and discharging of the batteries, and we are going to also see about the battery management system, how battery management system actually works, why battery management system is needed. Okay.